Finding Earth 2.0 has long been the holy grail of astronomy, a quest that touches on our deepest questions about our place in the universe. If we were to discover a twin of our own world tomorrow, a place with a blue sky, rocky ground, and liquid water, it would arguably be the single greatest discovery in the history of human civilization. It would mean we are not alone. It would mean that the miracle of life on Earth might just be a standard feature of the cosmos rather than a one-off accident. But to find a needle in a haystack of billions of stars, we need more than just hope. We need a new kind of eye in the sky. In December 2026, the European Space Agency is set to launch a mission that could finally provide the answer. It is called PLATO, which stands for Planetary Transits and Oscillations of Stars. While we have discovered thousands of exoplanets over the last few decades, most of them are giant gas balls or scorched rocks orbiting too close to their suns. The ESA PLATO mission is different. It isn't just looking for any planets. It is specifically designed to hunt for rocky, Earth-sized worlds orbiting sun-like stars in the exoplanet's habitable zone. This is the story of how we are about to begin the most sophisticated hunt for a second home ever attempted. To understand why PLATO is such a big deal, we have to look at the sheer scale of the operation. The telescope is designed to scan 200,000 stars with unprecedented precision. Most telescopes look at a small patch of sky for a short time, but PLATO is built for the long haul. It is going to stare at massive sections of the sky for years at a time. This endurance is critical because if you want to find a planet like Earth, you have to be patient. Earth takes 365 days to orbit the Sun. To confirm a planet is really there and calculate its orbit accurately, you need to see it pass in front of its star multiple times. If a telescope only looks for a few weeks, it will only find planets with very short years, usually those that are far too hot for life as we know it. By staring at the same stars for years, PLATO will be able to catch those elusive planets that take a full year or more to complete a lap. The technology behind this search is known as the transit method, and it is a masterclass in subtlety. Imagine trying to detect a tiny fruit fly crawling across a massive searchlight from several miles away. That is essentially what PLATO is doing. When a planet passes between us and its host star, it blocks a tiny, almost imperceptible fraction of that star's light. We are talking about a dip in brightness of maybe 1/10,000th of the star's total output. By measuring these tiny dips, astronomers can determine how big the planet is and how fast it is moving. But PLATO goes a step further. It doesn't just watch the planets, it watches the stars themselves. Through a field called asteroseismology, PLATO will measure the tiny vibrations or starquakes on the surface of these suns. This allows scientists to calculate the star's age, mass, and size with incredible accuracy. If you know exactly how big the star is, you can figure out exactly how big the planet is. This precision is what will allow us to distinguish between a cold, dead rock and a potential Earth 2.0. But why is the focus so heavily on the habitable zone? In the scientific community, we often call this the Goldilocks zone. It is that perfect region around a star where it is not too hot and not too cold for liquid water to exist on a planet's surface. Water is the universal solvent for life. Every form of life we have ever encountered on Earth requires it. While there might be exotic forms of life out there that breathe methane or thrive in oceans of liquid nitrogen, our best bet is to look for what we know works. Finding a planet with the potential for liquid water changes everything. It transforms a distant dot of light into a world of possibilities. It suggests the presence of an atmosphere, weather patterns, and perhaps the chemical precursors of biology. The ESA PLATO mission represents a massive leap forward because it focuses on stars that are bright enough and close enough for us to study in detail. Previous missions like Kepler found thousands of planets, but many were too far away for follow-up observations. PLATO is targeting stars that will allow other telescopes, like the James Webb Space Telescope or the upcoming extremely large telescope on the ground, to peer into the atmospheres of these worlds. We aren't just looking for a silhouette anymore. We are looking for biosignatures. We are looking for oxygen, methane, and carbon dioxide. We are looking for the breath of a living world. Think about the implications for a moment. For thousands of years, humans looked at the stars and wondered if anyone was looking back. We populated the heavens with gods and myths because the silence of the universe was too much to bear. In just a few years, that silence might finally be broken by data. If Plato finds a rocky planet in the habitable zone of a sun-like star just a few dozen light years away, it will be the most significant turning point in our understanding of nature. It would confirm that our solar system is not a freak occurrence. It would suggest that the galaxy is likely teeming with worlds that look and feel very much like home. Of course, space is vast and the challenges are immense. Even if we find a perfect match, reaching it is a problem for future generations. But the knowledge of its existence would fundamentally alter our perspective. It would provide a sense of cosmic context that we currently lack. We often treat Earth as an infinite resource because it is the only one we have. Seeing a sibling world across the void might remind us just how precious and fragile our own blue marble really is. It gives us a destination to dream about and a reason to keep pushing the boundaries of what is possible. As we approach the December 2026 launch, the excitement in the astronomical community is palpable. Plato will be stationed at the L2 Lagrange point, a stable spot in space about 1.5 million kilometers from Earth. From there, shielded from the glare of our own planet, it will begin its long vigil. It will watch 200,000 suns, waiting for that one tiny dip in light that signals the presence of something extraordinary. Each data point it sends back will be a piece of a map we have been trying to draw for centuries. The search for finding another Earth is more than just a scientific endeavor. It is a human one. It is driven by the same curiosity that led our ancestors to cross oceans and climb mountains. We are a species of explorers, and the stars are the final frontier. With missions like Plato, we are no longer just theorizing about what might be out there. We are actively looking. We are building the tools to see the invisible and measure the impossible. When you look up at the night sky tonight, try to imagine those 200,000 stars that Plato will soon be watching. Around one of them, there might be a planet where rain falls on rocky mountains, where waves lap against ancient shores, and where the sun sets over a horizon that no human eye has ever seen. We are closer than we have ever been to finding that world. The hunt for Earth 2.0 is officially on, and the next decade of discovery promises to be unlike anything we have ever experienced. Whether Plato finds a dozen candidates or just one, the result will be a triumph of human ingenuity. It will prove that we have the capability to reach out across light years and touch the surface of another world with the power of our minds and our machines. The universe is a vast, dark, and often lonely place, but we are slowly turning on the lights. One star at a time, one planet at a time, we are finding our way. If you are as fascinated by the mysteries of deep space and the future of exploration as I am, there has never been a better time to pay attention. We are living in a golden age of astronomy where the line between science fiction and reality is blurring every single day. Make sure to stay tuned as we follow the progress of the Plato mission and the incredible discoveries it is bound to make. If you enjoyed this deep dive into the hunt for a second Earth, don't forget to hit the like button and share your thoughts in the comments. Do you think we'll find life out there in our lifetime? Let me know what you think, and if you want to stay updated on all things space and science, make sure to subscribe and turn on notifications so you never miss a future video. Thanks for watching, and I'll see you in the next one.